Alright, draft physics video presentation, a response video to Franklin Who, and hopefully we can continue some conversation or dialogue about the specifics of what we can state as facts and agreed upon premises for some argument about how the jumping beans jump kind of thing. So, yes, we're just trying to solve a crime, so to speak. There's evidence, and you got to put it together and say who's guilty, who's possibly guilty, what's possible, what's not possible, who can we rule out, blah, 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 what can we rule out. All of that kind of conversation is in here somewhere. So I've played this portion of the video, 10 minutes of 27 minutes. And, I have to say it's always difficult, just because there's so many statements made that you just hate to let slide by and say, no, that's not exactly what I'm saying, especially when you're being paraphrased or your arguments being made. So a first point I will emphasize, try to make these, you could even number them, as arguments that need to be settled, things that need to be, there has to be some sort of agreement to just disagree and say, okay, because of that incompatible axiom, we really can't have a conversation because you see an invisible knife and I don't see it, and I have an invisible gun that I see, I see it and you don't see the invisible gun. So if we see completely different things, we can't really have a conversation much. So a first argument that I think we need to resolve, a first point that's kind of important, is what is a photon? I mean, how does it leave a surface? What's leaving the surface when one is made? And what's received on a surface, as a thing. Now, I'm arguing that a photon, by label, okay, is a sequence of events. It's a composite object, and that's where the frequency is. It's something that takes time to produce. It doesn't just instantaneously there's a photon has popped out of a surface. It doesn't do that. It takes time to make one. Takes time to receive one. So I'm arguing simply that whether you believe in this wave picture or you believe in what I would argue the more simple just nodes of momentum, that we could agree that, well, how can I understand red light and blue light in this idea? Well, I can understand it that the pattern is different, right? The blue light, the red light pattern is this, okay? So it's dot, dot. The blue light pattern is dot, dot, dot. The X-ray pattern is dot, 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 dot. And so that sort of explains what, that the thing doesn't just have polarization, like Franklin would agree that, a photon has a look like a pencil, like a thing, like it has more stuff going this way than it has going this way. But it doesn't say anything about what it has going this way, lengthwise. I'm saying a photon doesn't arrive at a surface and just hit it, photon. No, it's a sequence of events. It's a pattern. So it's a pattern. It's a composite object. It's made of more than just this. This is not a photon, right? So if I could just make that go through space, it wouldn't be a photon. It couldn't be seen as a photon. If a radio signal is coming, I can't just look at this, okay? I can't just erase these guys, and see this thing and say, oh yeah, that's 500 megahertz. No, I need these other ones to show up to tell me what the frequency is. I can't tell what the frequency is until this shows up. And obviously, if it's 500 megahertz here, and it's 250 here, and it's 100 here, I'm not going to be able to receive that with any receiver on Earth. So obviously phase becomes critically important because I have to maintain this dark space. That's the important bit, is the part where there's nothing. There's something, and then there's nothing, and then there's something, and there's nothing. Now he's saying there's a yin-yang, like there's a positive and a negative portion to this thing. That somehow somehow the space is compressed and uncompressed. So it's a plus and a minus. So it's and then the two slit would be, so you have a yin and a yang. You have yin, and then a piece of yang, and then a piece of yin, and then a piece of yang, and then a piece of yin. Maybe that's something he would argue is what he's saying the photon is, you know. And that maybe it goes and it makes double yin or double yang or double yin or double yang, and that's a photon. But that doesn't make much sense that it can be received as having yin yang, and then I put it through a 2-slit experiment and force all the yins to land in one place and all the yangs to land double and all the yins to land double, and somehow it still interprets it as a photon. Those seem like very different things. Sorry. Alright, so the first argument is that a photon is a composite object. It is not a blob. It's not a single bullet. So I agree, I say it's bullets, but it's not a single bullet. That's not a photon. A photon is, this. And more precisely, it's something like this. Okay, it's something like polarized, as it's moving parallel. These little bits are moving parallel, and that's a standard photon. Now when I break it and I put it in a slit, so we do agree. All right, so anyways, that's the first argument, is what is a photon? Do you agree it's a composite object, or that is time dependent, that is, it takes time to make one? Like one electron has to jiggle here, and another electron has to jiggle here, and another electron has to jiggle here, and those 3 jiggles will end up being the photon. Something like that. It might have 10 of those in this spot. It might have 10 here. It might have 10 here. But the idea would be that would be 10 photons. It's not that this would be a photon and this would be photon. It still has to have all 3 of them have to show up. And it could be 4, it could be 9, it could be 17, it could be 1,000. I'm just saying, we just pick an arbitrary number to say this is how many units of frequency you need before you can tell it's the right frequency, before a surface can tell red light hit me or blue light hit me and react accordingly. And that goes back to my whole tipping point argument, which, there's more complex arguments I can give you, but obviously you have demonstrated that you are in some condition where you have I have to be conscious of time, and so I will try to be as considerate as possible of that, and just say I can give you a more complete explanation, but it takes time, and it's all dependent on whether you're willing to expend the time. Alright, so I'll pause and get to the next point. Alright, so the next point would be is that we agree that when this slit experiment happens, most of the light's just going straight through, and that the only action is at these surfaces. And the real truth is, I would argue, is that, well, it's probably not the best way to say it. The real truth is, he's claiming that there's some geometry in the universe, okay, that's like there's an ether and there's a geometry, and the diagonal lines can't be taken because they're jagged. You have to go 1 up and 2 over and 2 over and 1 up, and it's too, and so there's only certain pathways through the geometry. Now I'd argue that geometry kind of forbids any of this idea of any diagonals at all. They're all ruled out because they're longer distances, and you can't have a constant speed of light then, and how does the light know it's moving a longer distance? It just doesn't work. So in my opinion, that's one of the big downs for ether, is you can't make straight lines through it. It has no geometry. There's no geometry that satisfies the problem. Now he brings up electron experiments, which I really hate. Let's just try to stick to photons or electrons and not mix the two, because they're really different things, fundamentally different. So I would argue for the electron experiment, they really break the rules, right? We know this is a really simple experiment, right? You just scatter photons at the slits. The whole idea is not to shoot them in a straight line, but to shoot a whole bunch of them all kinds of directions. That's the whole point. Well, when they do the electron experiment, why do they have to put a whole bunch of magnetic lenses in the pathway of the electrons if scatter is what you want? You want them to be going in all kinds of different paths, so why would you put a bunch of lenses before you get to the slits? All right, and then you have the focal length of the last lens exactly where the slits are. So now you're condensing the electrons. Now my simple argument about electrons is this is where we go to geometry. This is where you can understand that electrons hate each other, and there's an ideal geometry for electrons. The ideal for stuff that hates each other, if you had to manage 10 cats that hated each other, you could come up with this ideal geometry, okay, where they're equidistant from each other and all of their potential hatred is mitigated, by having this off-center geometry. So all of a sudden that looks an awful lot like lines. When you look at it, you end up with lines here, right? I mean, that's just kind of obvious. You end up with these lines. And that's the geometry electrons are most likely to get into if you leave them to their own devices. If you'll just let nature take its course, and you say they're all equally charged, equally repulsive, equally stinky, equally making noise, equally creating pressure, this is the geometry they'd all fall into eventually, is they'd just end up in this line geometry. Just a fact. So it's not a big surprise that electrons line up. It's just not a big surprise, I would argue. But I don't want to argue electron experiments because they're way too complicated. They're all taking place inside of electron microscopes, essentially. It has nothing to do with this simple experiment. So anyway, Franklin agrees that all the action is here at the surfaces. So part of agreeing to that is to recognize that then how do you draw your waves? Because I would argue the only way mathematically you can account for the pattern, that is, you can do your path length differences from these surfaces. The only way you can say this is one wavelength different than this, the only way you can say that is you have to draw these waves in this insane location. They break here in the middle, your wave broke in the middle, and it's going through the surface. So that doesn't make any sense at all. So I mean, wave theory is destroyed. I mean, the conventional theory is destroyed by this simple logic. And then especially when you get to the two-slit experiment and they still are drawing two waves, which doesn't make any sense because now we know there's four surfaces. So two waves certainly aren't going to do it. And it's a very complex pattern created that certainly isn't just drawing two lines. Two lines won't give you the right pattern. So that's been demonstrated by me clearly. And so lots of other factors in here. The idea of equidistance. You can't measure the distance to the target and then pretend the distance to the target is the same. So this target, if I drew two vectors to over here, the conventional math is, oh, well, that's the same L as this L. Somehow this distance is the same distance as this. I mean, it's such ludicrous, bad mathematics. I mean, it's overtly so silly that you would actually propose that this L, the distance from here to here, is the same as the distance from here to here. You have to know that math is going to fail, right? If it's assuming this distance is the same as this distance, it can't possibly be getting right answers, right? So obviously when they do the math has the same L, which means this is the point. When they're talking about this, they're really talking about this place in space, because that has the same L as this. Anyway, I've pointed out how the first node isn't really an actual node. That this equidistant node happens within 1 millimeter of space. It's a tiny, tiny little node. It's inside of 1 millimeter. You obviously couldn't see it. It's so tiny. It's such a tiny node. And that's where they get all this experiment all wrong, is they start counting from here when they should be counting from here. This is the 90 degrees. At 90 degrees is where you see the real difference between this slit and this surface. You see all of the wavelengths are there in the difference between the path. And so if you have an odd number, a non-whole number, when you divide the wavelength into the distance between the two surfaces, if you have 15.5, well, that means right here has to be dark because now they're out of phase. So the other point, I sort of just wanted to get to that to get to the phase argument. Franklin is kind of implying that phase isn't important here. That's a false positive. That's it's distracting people. But it's so critical to the math, and I just don't know how you can break it as being fundamental to the whole function. Hold on. All right, where was I? Erasing. Yeah, so it's blank again. So anyway, I don't know how you can I don't know how you can think phase isn't fundamental to the idea of what you recognize. This is a little bit annoying. All right, should be safe to go back in the water. Yeah, the phase argument just seems so fundamental, and so he's arguing sort of that in my theory, where I kind of overtly state that yes, it actually does do this. I'm saying the little bits of the photon get scattered. So you have a pattern, dot, 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 and the dot, 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 one piece goes here, one piece goes there, this piece goes over here, let's say. And another photon goes in, and its dots go here, and this dot goes there, and this dot goes there. So yeah, it gets spread all over the place. But the fact is, it happened at a time. And the fact is these lines have a length, and they will reconstruct photons, dot, dot, dot. It will go back to being dot, dot, dot again. And so it's just the law of averages that, yes, in half the places, it's going to be back in phase, and in half the places, it's going to be out of phase. But that's the only thing you can break it with is the phase. And the only way you break the phase is by changing the distance. So there's nothing forbidding about that. So yes, energy hits here. It's just that it's out of phase. It's not a red photon. It's not a blue photon. Not a green. It's not in the right shape. It's two dots too close and then one too far away. And if it was 5 things, you could have 2 far away and 3 too close or whatever. It's not the right arrangement. It's not the right frequency, and the tuner isn't going to be able to pick it up. The frequency has to be consistent, or you don't have a signal that can be deciphered. And clearly the matter can't decipher that. And so I've used the tipping point argument, but this is about hitting electrons where you add energy to their system. So if I was to draw it as just a pendulum that swings back and forth, I guess I could draw it over here. You can just understand that there's going to be certain frequencies that'll add energy. Push, wait, push, wait, push. That'll add energy. And then there's frequencies that subtract energy. And the simple argument for electrons is that when a piece of a photon hits an electron, it moves it. So a little bit hits, it moves the electron. Well, if another little bit doesn't hit, within this, before this electron goes back, because it wants to go back, we know that, before it goes back, then it's going to be, the next one hits while it's heading this way. Well, it can't add energy to that electron. It's going to subtract energy. So, so the reason why certain frequencies move electrons in certain atoms is because the atoms all have different tension on their electrons, and some will have to be hit at a different frequency than others to be able for it to be constructive. So only certain movements are constructive, and then it explains the ultraviolet effect of when you shine ultraviolet light, because it has our X-rays or gamma rays, that if you have the highest frequency light, it's always additive because you hit it before the electron even thinks about going back. You're hitting light while the electron's still moving away. You hit it again. You're obviously adding energy. So you don't have any energy adding problem with high frequency radiation. That's why it pops electrons so easily. And depending on the energy, if I shoot X-rays at, I get even more action out of the electron in terms of how it leaves. So that's perfectly sensible. It all adds up. All right, let me see if there's any other points that need to be further clarified. All right, so further elaborating on understanding what a photon is and how we can dissect what it is, I would argue that there's no evidence that photons can be used to shadow an electron. Like we could shine photons and then we could see the electron shadow. That something has to be a certain size before it can even create a shadow. And that's sort of demonstrating that photons have to hit more than one electron. They have to hit more than one thing on a clump of matter before you can have a photon. That what we call a photon is really an event, and the event is electricity. It's creating a current, and that's really what a photon is it's causing an electron to be forced to move through a piece of matter from atom to atom to atom to atom. That's a photon. And if the electron doesn't move from atom to atom to atom to atom, it's not a photon. All right, so we can play some of this safely now, and we'll just do some of that. I won't play the whole thing just for brevity and such.
those certain stripes, and you can put them in one at a time, two at a time. It doesn't matter because they're not actually interacting. So, but they say they're.
So, okay, so he's talking about electrons and he's saying the electrons don't really interact. I would argue exactly the opposite. Electrons are charged, they're always interacting. Doesn't matter whether they're moving or not moving, doesn't matter, they're always charged, they always hate each other, they're always repelling each other. And I suppose theoretically you can move them fast enough where they can't reflect any energy to each other so they can't see each other, but they're still going to be producing the reflections of the energy. They're still going to produce, like say if I go at the speed of light, I'm still going to be reflecting light off the side of me. And so there's still going to be a profile I'm leaving behind in the universe that says to another electron, get away from me. So the sideways part is still going to exist. Now, yeah, my stink might drift far behind me, but it's still going to exist, and it's still going to affect the electrons further back in the ray and all that stuff. So it's still going to move them around. All right, anyway, so just clarifying that point.
Interacting. They're saying because there's a diffraction pattern that the electrons must be away.
So again, this word diffraction, it's really got to be clear that diffraction just means spreading. All right, so it really shouldn't be anything called a diffraction pattern. All right, because you really need interference to create the on and off kind of stuff. So saying there's a diffraction pattern, I think, is incorrect. There's no pattern to diffraction. That's just spread.
And so I'd say no. I think this is all just due to a space quantization problem.
Right. So he's saying the space has got some kind of geometry, and there's places where the geometry is straight. Like you can go, you can hit marble, domino, 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 and then there's places where there's half dominoes, and you can't go that way. And then there's whole dominoes again. But I would argue that doesn't make any sense because how does it vary based on size? So if I move the slits a little further away, somehow the geometry completely changes, and now the safe paths are much tinier. So if I move the slits apart, the safe paths get much, much tinier, a million times tinier, right? And then if I move the slits closer together, somehow the safe paths are only 3. Just doesn't really make sense. Especially if you're going to agree that the pattern is coming off the surfaces.
Okay, so I think that's most of my response to what I had to say about his video. I mean, it's like, I get Gary's argument. It's like,
so he's done. He's done with the video, and he's still got 17 minutes to go. So I like Franklin. He's got a lot of my bad habits, and he's got a special cabinet. I mean, that's so cool. I mean, that cabinet just screams, "Oh, there must be like Confederate money hidden in there or something." That's got to have something really special in it.
Possible that light can be these little clumps, and it's possible that you can get what look like diffraction effects, and it might not necessarily be due to
Yeah, I know, but that's sort of what the argument I'm making is that all these possibilities can be kind of eliminated as you start to dissect. And so the point would be is like dissecting the fact that if I do the simple thing of just putting a string, from the 2 point sources, and you can just put the notches right on the string at 90 degrees, and then you move the string to 0 degrees, and now half the notches are on one side and half the notches are on the other side. It's kind of sort of just screaming to you, yeah, those are the path length differences. And the irony is that even though the 2 pieces of string are the same length, it doesn't mean the notches match. You could be right in between 2 notches. So the 2 strings are the same length saying they have to be in phase, but the notch is saying, no, it's completely out of phase. So, it's those little tricks that tell you everything about how this thing has to work. And it's that little trick that explains why the single slit has this big giant node in the middle. Because it's really 2 separate nodes that started here and started here. There was technically no middle.
wave. But when you kind of weigh things, it's like, well, yeah, we know totally for sure that a wave can create those patterns, right? That's like the simplest thing.
Okay, that would be what I'm arguing is it's nowhere near that simple, right? So if I just draw this simple Young experiment, right? I have 2 openings and I draw 2 waves coming out of those 2 openings. That won't work. It's explicitly wrong. Nobody uses the math where they say the center of the openings is the distance I'm going to use in the math. No one does that. There's no math that'll work. It won't give you the right pattern. So again, you can say, oh yeah, waves are just so right. It works so well. No, it completely fails. It catastrophically fails in the single slit because in water there's no pattern at all. And it fails in the double slit, and we know that the double slit pattern actually has two patterns in it. And two vectors will not draw those two patterns. It fails completely to describe the experiment. So I'm just saying, you can keep saying, oh yeah, well, waves just have so much on their side. Not if you really look at the experiment. They don't have anything on their side.
And we know exactly how that works. We can demonstrate it in wave pools, and it works out all perfectly exactly the same.
Except it doesn't work. That's the whole point. It works in a wave pool. That math will work. But it doesn't work with light. You don't get the right pattern. It's fundamentally a different pattern. I mean, you have to concede it's fundamentally a different pattern, right? The classic double slit pattern is nothing like what water waves make. So, I mean, why do I even have to make the argument? I shouldn't have to make the argument to you. You know what the real double slit pattern, right? You know that it has little bars, and then it has big bar envelopes. So there's blobs of little bars, then a blob of little bars, then a blob of little bars. There's two patterns. Two waves won't make the two patterns.
Versus supposing that they're particles, and you have to deal with these phases and have to deal with this, magic.
The phase is just so kind of obvious, right? I can have bullet number 3 can be bullet 1, and then bullet 4 from the other place could be bullet 2. It depends on the path length differences. So I can take a pattern, I can break the pattern, and I can remake the pattern. So it works fine. There's only a 50-50 choice, right? I mean, I can send them scatter. I can scatter something, and there's a 50-50 chance that they're going to be a wavelength difference away or a full half wavelength, and everything in between, of course. But I'm just saying the two choices are 50-50. The two generalized outcomes of being close enough to being called in phase or close enough to being called completely out of phase, those two choices are 50-50. I can't miss. I'm going to get 50-50. And that's exactly what the pattern is demonstrating in a way. I mean, obviously the bright spots are a little bigger than the dark spots, but they'll even out over, if you think about it, it has to even out.
Cool thing about if all the particles don't all get there at the same time, you won't be able to see them.
So nothing gets there at the same time. The whole point is to recreate a pattern. Dot, dot, dot. Red light. Dot, dot, dot. Blue light.
Stuff like that. So I still prefer to think, and for other reasons, that the reason why we get the diffraction on light waves is because it is a wave effect. But
well, I'm just saying that I have, through analysis, demonstrated that there's no math that can make that make sense. So if you want to draw me where the wave is, you've already conceded that the whole experiment is on the surfaces. So then you have to draw your wave on the surface. So I'm just saying, how can you explain how the center of your wave is on the surface? How do you explain why in a single slit it broke in the middle of the opening? And how do you explain how it went through the other side of the surface? Because that's what it has to do. When you reduce it to a point source, and that's what it is, when you reduce it to its smallest scale, that's where the wave is. So how do you explain why there's waves in those locations?
So let's get on to the second subject of the talk here, which is the generation of the magnetic field. So I made a super quick video, and it was super quick because I was about to go on vacation, and it was a minute and a half. The world's shortest video.
Okay, yeah, it was short. All right, so I'll stop here and I'll save that for a magnetism separate subject. So why mix the two? It just gets messy. So I will read a comment, on the slit experiment, just because it's just such a snarky pile of crap. And so I obviously deleted and blocked the asshole. I didn't keep his name though, so I don't know who he was. So that was my bad. I should have wrote down his name for posterity. But he's off the hook. He's not going to have to be accountable after all. But it's just such a stupid comment. I mean, there's nothing, it doesn't even come close to dealing with a single point raised in my video. I mean, just nothing. So there's a 17-minute video on the 2 slit, and it just dissects it completely. It's done. It's cooked as a wave theory. All right. You haven't demonstrated anything near a detailed enough explanation. Well, it's as detailed as yours. See, that's the trick here. They keep saying I have to produce some sort of evidence. They've produced absolutely nothing. So the double slit experiment has existed for 200 years, and they don't have any detailed analysis at all. There's not a single video on YouTube where any kind of, yes, we measured the exact width of the slits, and then we measured where the pattern was on the wall, and we measured the distance, and we did all that crap. They never do any of that crap. So you talking about how I have to produce detail, no, I don't. And as I've demonstrated, it's exactly the same math. I'm not using a different distance than they are. I'm using exactly the same distance. I'm using the same lambda, the same wavelength, and all I'm doing is getting to the answer quicker. So I am doing a derivative of their equation. I'm just saying simply all I have to do is put the wavelength into, okay, the distance between the surfaces, and I can automatically tell you how many nodes there are by simply multiplying it times 1/2 of pi. And that'll tell me exactly how many there are in that 90 degrees. I mean, well, it's 180 degrees. So I guess I should multiply it times 1 pi. No, I'm not sure of that. Anyway, we won't go there. Well, the pi tells you how far away and how big they'll be that far away. It's the same number of nodes. There's only the number of wavelengths tells you that there's only that number. Whatever that number is, that's exactly how many places there are where there can be a full wavelength of difference. There's no special amount of them. There can only be that number of places. And again, the pencil and the string thing just proves it all. Okay, you go from here, it's the full number. So whatever the wavelength is, at 90 degrees, the wavelength divided into the distance between the slits tells you exactly how many nodes there are. And all you're going to do is take this and make your arc. So you're just going to do the pi thing to tell you where the distance is. And so you just put those on that arc. Because you know at this, half are on one side and half are on the other side. So you know that is halfway. So it's half at 0. So the full number of wavelengths go across the whole screen. So if there's 15, if 15 wavelengths fit in the distance, then there's 15 nodes. There's 15 fringes. That's all there's going to be. The 180 degrees will have 15 fringes. Because there's only 15 locations where you can have a wavelength of difference in the length of the lines. Demonstrated. You haven't derived the single pattern. So whatever the single pattern is. Okay, that's what it says here. You haven't derived the single pattern. You could have said a single pattern maybe, but clearly I derived it. Clearly I showed you exactly how the mathematics works. There's no other way around it. I showed you the path length differences. I showed you the vectors. I showed you how in every way how they're created and how this is the only way, these are the only points that will allow you to have a full wavelength difference. I mean, I pointed at all of it. There's no hidden anything. Anyway, there's no missing anything. You haven't derived the double slit pattern. Well, that's exactly what I do. I demonstrated exactly why there are two patterns. I pointed out that the two closest surfaces are defining the envelope, and the two farther, the biggest distance, is defining the little bars. And there's absolutely no inconsistency with their math. I'm not violating their math. I'm just doing it in a shortcut. I'm not bothering with sine theta. I'm just saying I already know it's a circle. I don't need sine theta. I know it's a circle, okay, and I know the radius, the relationship is pi to the circumference. I know it's 4 pi. I mean 2 pi for the circumference. So what do I need to worry about any of that crap for? I don't need any of that crap. I don't need sine thetas. I already have the length of the circumference. All right. You haven't derived the double slit pattern, which would just be a bunch of single slit patterns on top of each other. So that's exactly the ignorant answer. Well, it's exactly not. Because without the single, how can you have the longer distance without the other slit? You can't possibly have the longer distance. So all you have is this distance. The second slit means now I have this long distance from the edge, the end to the end. And that's the one that's actually creating the little bars. So, it doesn't, you can say that it's just the same pattern projected on top of itself, but it's not. And clearly the path lengths, if you draw them, will show you that it's not. Without the second slit, there's no possibility of having this longer line. Is there, retard? Oh no, there really isn't. You can't have these much longer path lengths without the other slit being there, can you? Unless you put your two slits right on top of each other. I mean, what a dumbass. Okay, not what we see. So that's just a lie. Okay, there's absolutely, you have no evidence. You haven't produced it. You haven't posted the link. I keep requesting the link to the two-slit experiment analyzed correctly. Not a single person has posted me a link to the video they would stand by. Not one single link to one single video out of the million videos, the 500,000 anyway, the 253,000 videos on YouTube covering light diffraction and interference. Of those videos, not one person has posted me a link to one they would stand by and say, yes, this one accurately describes the pattern. Not one. And in spite of the fact that I'm offering $1,700 for some channel to play my 17-minute video and then point out how it's wrong about anything, $1,700, free money to just make fun of a 17-minute video and no takers. And you're telling me I don't understand something? No. You're the clueless asswipe. Alright, anyway. You don't understand what it means to be detailed. No, you don't understand what detail is. Detail is, you think the Eddington experiment, an experiment done 100 years ago with inferior technology, doesn't need to be repeated. And certainly not with 400 times better space technology. So the space technology is 400 times better. You've had 50 years to use it, and you haven't done it. And yes, it's a cornerstone experiment. Einstein would be nothing without it. Nothing. He'd be irrelevant. Okay. You just run your mouth off. No, you just run your propaganda reel. You just, like all the other religious kooks, you just sit there with your fake evidence, your false, phony bullshit. Oh, here's a Tyrannosaurus paw print with a human man's print right on top of it. You just keep lying. Okay, like a religious shit. Alright. Off like Ken Wheeler. Yeah, Ken Wheeler can make no drawing that ever will make any sense. So go ahead and show me the comparison between what Ken Wheeler states, everything is curved oxymoronic, versus the fact that I'm just arguing that, yes, the real world is straight lines, asshole. Okay. And pretend you're doing anything reasonable. Well, the fact is that I'm offering you $1,700 to any little friend of yours on the internet who actually has a meaningful YouTube channel. I'm offering them $1,700 to prove they're smarter than me. $1,700. And they won't take the money to prove they're so much smarter than me? I'm such a dumbass and I'm so fucking unreasonable. Then why don't they take the fucking money? Alright. And the irony of you calling other people's cash prizes out. How is it an irony? I'm clearly paying them for something simple. Play the fucking video on your channel and then decide whether you want to say anything or not. I don't even care. You don't even have to say anything. Just play the 17 minutes. Now, is that very difficult, a contract? The other asshole said I had to prove something. Well, we know, what do you mean by prove? You mean prove to your mother? Who do I have to prove it to? Alright, anyway, just mind-blowing how little self-awareness you have. No, it's mind-blowing that little arrogant pieces of garbage like you, human trash, what kind of fucking slut and what kind of idiot gave birth to you and raised you, that you talk shit like this, shit, unaccountable shit, you nameless fucking troll account, and you talk this kind of fucking goddamn shit, and then you point your finger at anybody and talk about their character or their integrity or their reasonableness or their intelligence. God, you're such a piece of human garbage. You have no integrity. You're a lying, scurvy little fucking goddamn worm. God, you should be outed. The internet shouldn't even allow pieces of crap like you to stomp around and make noises because you're unaccountable. Okay? I'm here. I'm accountable. Alright? I have to take responsibility for the rest of my fucking life for what I say. You take no responsibility, you fucking weasel. You're fucking wrong as hell. I'm going to prove it. And then what are you going to do to make it up to me, asshole? what kind of way are you going to correct your egregious crime against me? Oh yeah, that's right. You can't fix it. So all I can do is hope that the future pisses on your lousy, scurvy grave as a lesson to all the other big mouths that this is what you're going to get. You're going to get soaked in urine forever. Because that's what you deserve, you piece of shit. Yeah, okay. I like that. It's like taking a big poo. Yeah, that was good. I liked it. So, till the next time and such.